All right, in case anyone joins us online, I'm recording things there. I'm sharing on Zoom, but most of you are here. There's a lot of you here. Hello. So yeah, welcome to the SED-ML session. Given the number of people here, I'm guessing that some of you probably are less familiar with SED-ML than others. Is that true? Is anyone less? Okay, good. I have a different presentation. Okay, I'll just try to give you the basic overview of what SED-ML is. What's that? Sing it. I will sing you what SED-ML is. SED-ML, okay. SED-ML is a way to record in a computer readable form and what you are doing with your model. So if you want to, the basic thing that it was designed to do was record I'm simulating in time for a certain number of, certain time period and a certain number of points. I load in a model, I tell you what it is. I say that I have a simulation that will record that I'm simulating for a uniform time course for a certain number of points. And then I say in another object, I say like, do this simulation on this model and produce the results. And then there are what are called data generators afterwards that you use to describe what those outputs are. And the output is reports and plots. So I can say like, give me just a CSV file with all the values, or plot it to the screen, or make a plot, write it to a file, do it to the screen, something that will show me what the results of the simulation was. The ultimate goal, or the original goal of SED-ML, was to be able to reproduce a figure from a published paper or from any paper. So that you could say like, basically all the semantic information in that plot, you should be able to record in a SED-ML script or in a SED-ML file that would be able to tell a computer how to reproduce exactly what was in that original file. Does that basically make sense as the goal? The details, we're going to get into the weeds here, and I apologize that for some people. Let's see here. Okay. So yeah, the history is that SED-ML came out many years ago, like 12? I don't know, maybe about 12 years ago or so. SED-ML Level 1 version 1 did basic things. Level 2 added a few things. The latest version of SED-ML is Level 1 version 4, and it was produced. It was actually officially published last year in September. So it's been out for exactly 1 year. A lot of details were put into the spec that had sort of been known by the community, but weren't like formally written in the spec. So a lot of things, like, and one of the things that helped was that some of the people from outside the community started coming in and say like, we'd like to use SED-ML, and you don't describe what you do well enough. So I'm like, oh, okay, I guess we should describe that in more detail and in this form or another. Various people have used SED-ML over the years, and people were starting to use it in ways that we didn't predict. One Combine meetings, some plant biologists had like just text-based models of their plant biology models, and they wanted to use SED-ML for it. And we had assumed that all models are XML because that's just what you do when you make a model, right? So they were like, they just used our constructs, and like we claimed that you had to use XML for them, and they just didn't do that because they didn't have an XML model. So, and in more recent years, and in fact, just over the last 2 or 3, our group, in combination with biosimulators and biosimulations with Jonathan Carr, started trying to expand SED-ML to cover different models and stuff. In particular, the BioNetGen language, which is very similar to, it has its sort of roots in SED-ML culture, I guess. But it is also a text-based language, and you can't address elements of the model with XML constructs. You have to say like, it is just this string. And so one of the things we did with level 1 version 4 was expand things so you could refer to model elements or model analyses in new ways that were more sort of generic. And you didn't have to say, these are like the 3 things that you can do in SED-ML. There are general ways to talk about anything, and there are easier ways to introduce new analyses into the mix. So at Harmony in 2021, so a year and a half ago or so, we sort of talked through as a group at the meeting what we wanted in a new version of SED-ML, because there are a few things that turned out to be really obnoxious about SED-ML. It works, but there's some certain things that are friction points. And a lot of these things were things that people have said, like, these are friction points, these are something we really want. If we're gonna sort of do a level 2, which is a sort of a reimagining of what SED-ML might be, this is what we would want. Workflow descriptions. I'm sure there's someone who doesn't know what a workflow is. Workflows are ways to repeat exactly what you did. And they're often used in concert with Docker images. So you say, grab this Docker image, run these exact commands on it, collect these, like this will write to a file, grab this file, plot it with this thing. And it is a precise way of describing an experiment again, but in no way is it generic. It is very hyper specific. Like, you grab this particular thing, you run this particular program, you do this particular thing. That is something that you should be able to produce from SED-ML, but SED-ML is designed to be reproducible. And when I say repeat, I mean do exactly what you did last time. And when I say reproduce, I mean do the concept of what you did last time in a new system. So maybe I use a completely different simulator. Maybe I used Tellurian before, and now I want to use Coposi, or the other way around. Or even as simple as I ran Coposi on Windows, and now I want to run it on Linux. If I'm repeating something, and if I'm using a workflow language to do that, that doesn't work. I would have to write up a whole new workflow that describes how to do something in Windows versus how to do something in Linux, because like command lines are just different. So what SED-ML should do is describe in general terms what we want to do, that you can then translate into a particular workflow. But we definitely want it to be more compatible with workflows than it is currently. So yeah, that's what I'm talking about, reproduce versus repeat. It should be easy to define just a model of simulation results. That should be like, that's our basic like loop of what you want to do. That should be the simplest thing possible in the world. There should be clear definitions of data types and the data dimensions. This is again something that SED-ML assumes you know. It says like run a simulation, and it assumes that you know that means you will get you'll get results of a certain dimensions. Or it'll say like repeat this 5 times, but it won't really describe that the result should be a 3D matrix of data or something. It should support parallelism. There's a lot of high computational needs. People want to run things. People want to run a lot of data and a lot of simulations at all the same time. That would take a month if you were to run it on one core, and they wanted to like compress that time so you can run it on a cluster and get it done in a week or a few days. And the SED-ML, again, SED-ML can be tweaked. The current version can be tweaked so you can figure out how to do that, but it's not easy always. You should be able to transform complicated output of one step into input for your next step. So you should be able to run something and get a result and say like, I want to use that result as my input for my next step. And that's also not something that's always obvious how to do in current versions of SED-ML. One thing that you absolutely can't do currently is sort of outsourcing any sort of simulation. You have to be able to describe in current SED-ML exactly what it is you want to do. And there is some desire for things that are unusual or outside of SED-ML scope or something else. Say like, actually for this bit, I want to run this program, and you're just going to have to run that program. And maybe it's somewhat generic, like outputting a plot. There's a lot of details that you can say about plotting, and people want to use Vega as an example of a way to describe how to produce a plot. And we don't want to like import all of Vega into SED-ML just so you can redescribe it in SED-ML and then export that to Vega. It seems like it would be easier to just do that in Vega and just do the basic semantics of what your output should be in SED-ML. It should support any modeling language, which it currently does. It should continue to do that. It should support current and future modeling frameworks. We've been able to slowly expand things to talk about FBC, flux balance stuff, qual, basically like Boolean networks or things, agent-based network modeling, anything, or like the random people that show up at Combine with a completely new modeling system for plants. So we're like, yes, sure, we can support that. That's fine. Another thing, we should be able to connect to different tools. That's a thing that is not at all possible, or I mean, it's not possible with the core elements in SED-ML. Like I want to run a simulation on 2 different simulators and compare the results. All I can describe currently is to say, run the simulation twice and compare the results. And the fact that I wanted to run them on 2 different simulators is not something that I can encode in core SED-ML. And in general, we want to provide scalability as users develop the experiment. So users should be working in a system. The basic things should work, and then as they expand, they should continue to be able to use SED-ML for any sort of level of complexity. So that's a somewhat shortened and condensed version of the whole thing. And I will try to post these slides, so if you want to look at the whole thing, you can later. Or just if you look up SED-ML Harmony 2021, you might find a link there too. So yeah.
I think a big thing we came up with is modularity, and that we currently see that with the current SED-ML, many tools support it, but every tool is only supporting like some subset. This makes it very difficult to compare SED-ML between different tools. And like also the different tools and workflows are specialized in certain things. Some tools are very good at visualizing things, others are very good at parallel simulation.
Yeah.
So the idea is when they have modular things we can put together, and everybody can clearly specify which problem she
yeah.
can solve, and so that everything can be put together.
Yeah, I think that's true. Yeah.
Maybe now document, and if you want to really actually execute what is there, then to implement support for it. So SED-ML is not executable as itself.
Yes, that's true. So just like, yeah, basically, so SED-ML describes a simulation experiment, but it is not that. I guess you wouldn't. You have to translate it to something in order to get it to actually run. So, like one typical way to do that is to parse the file and then produce a Python script that actually runs the SED-ML and actually like calls the different programs that does do the simulation, uses matplotlib to do the plots, that sort of thing. So there may not be a single program that can interpret all of what's in SED-ML. Although some tools like Coposi has integrated SED-ML support, so it will load a SED-ML file, and if certain characteristics are made, it will say like, oh, that's what you want to do, and it'll set up everything in Coposi so you can actually run it. Tellurium is also Python based, but you can say like load the SED-ML file and run it, and it will again use matplotlib in the background, use Roadrunner in the background to do the simulation, and run through and produce the results for you.
comment on that.
Yeah.
In reality, it's much more complicated because the models and also the SED-ML, they can see many details which is unclear if the simulator is supported. For instance,
Yeah.
if you know you can run a time simulation, it doesn't always mean that you can run it fast. The model with delays or some feature of SED-ML like fast not supporting it, then the SED-ML can't be executed. So it's important like also that the tools provide an important what features they support for what languages and so on.
Yeah.
The whole system very complicated, but everybody can do something and all the standards can do very much. And so in the end, it's unclear if things can be executed or not.
Yeah. Yeah. Yeah, that'd be nice. And right now, the state of the art is that if you are writing a SED-ML interpreter, you just have to know what each tool does and what it doesn't. So you are like, as on the SED-ML interpreter level, you are like interpreting what the SED-ML is asking for, and then you look at your suite of tools and say like, all right, you can do that, and you can do that. One thing that SBML has that that's really useful is called the SBML test suite, which has been around for a couple decades. And the SBML test suite has 1,400 tests in it that all test different aspects of the SED-ML, of the SBML standard. And it all comes with tags. So if you want delays, there's a tag that is delay. And so if your simulator doesn't support that, you know, like, okay, I will flag my simulator is not supporting that particular type of thing. So for SBML, we have a pretty good list of all the different things that SBML covers that an individual simulator might not cover. And that's sort of the level at which you want to know these things. Something that you might encounter in the wild, but that a given simulator might not be able to do something with. Are we good? Other comments? Obviously, feel free to interrupt me at any time. So what I have today is my own vision of what covers that general thing from the other day. And I cannot overemphasize that this is me as opposed to the community. And in order to be a good community standard, it has to be more than just me. So this is just sort of an introduction, sort of like, here is a way we could do things. If we want it to work, it's going to need more work. If we decide as a community that we don't want to do things this way, that is fine. Like, we don't have to do things this way, but this is a way it could happen. But that being said, I'm going to go into the weeds. At its core, what this has is a script class or object that is designed to be procedural. And that's one thing I didn't mention earlier, but SED-ML itself currently is all declarative, which means that you just say, here is a model, here is a plot, here are results. And you have to sort of say, as an interpreter, oh, if I want to produce these results, I'm going to need these data generators to produce those. And if those data generators require the simulation, I'm going to need a simulation for that. And if that simulation requires a model, I'm going to need the model. And you almost have to work backwards just from these general statements of there should be a plot to this is what I should do in my interpretation. So what this does is, instead of making you work backwards, it just says, do this, then do this, then do this, then do this in a procedural form. So that's the basic idea. The biggest change, I would say, is just that. Is just that it acts like a script. Do this, do this, do this. I didn't worry about backwards compatibility. That said, I also didn't change anything that I couldn't think of a better way to do it. So I didn't worry about like changing things, but I also didn't change things just to change them. I also have produced there has been some discussion about whether or not SED-ML should be XML at all. And I went ahead and designed this to be in with UML diagrams, which is very sort of XML like oriented. But you can imagine having continuing to do things as XML just as we always have. You could also have a different form, JSON databases or YAML or something else. And again, I hope that this part is just more of this is the design, as opposed to this is like we should definitely keep XML or not. I'm sort of agnostic on that end. So in this proposal, there are top level scripts, and then there are some global objects that those scripts use. There are models. You define models that then the scripts are then pull in as they need to. There's external data that you might pull in. I didn't mention that in my introduction, but one thing you may well want to do is I have a model, I run a simulation, I compare it to collected data from a spectrograph or something, and then like look at the difference and report the error differences or something. You can do that with current SED-ML. You should definitely be able to continue to do that. And then you have user-defined functions, which are basically just scripts themselves that then these other scripts can call. So there's at the global level, there are scripts, there's models, there's external data. Technically, there's also styles and global algorithm parameters. But in general, the first three are sort of conceptually what the other scripts are using. Yeah? Yes. Yeah, a script can call a script and whatever. Yeah. Mm-hmm. Sorry, say that again. To initialize the model. Yeah. Yes, you could absolutely. Sure. Now do this, now do this. Yeah. You should definitely be able to do that, I think. Yeah. So this is an example of a script form of a really simple example. So this isn't what you would actually store, but this is just because the other thing I could show you is this, which is a little more awkward to know what's going on. So I define a model, call it mod1. I define sim1 as the results of a uniform time course, which is a predefined function that uses mod1, sets things up just like a regular function. So like start at 0, start collecting data at 0, go for 5 seconds, collect 50 points, and then plot it. And then I just take the results and say plot those results, and call it figure 3. In YAML, this is what it would look like. I'm going to use my mouse instead here. So we define the model here. We have a list of models, and of which there is exactly one. We define what language it is. It's SED-ML. It comes from this file name. And then also, this selection list is new, and I'll talk more about that in a bit. But this is like, it helps define what the output is. So when I'm running a simulation on it, like when I'm running this simulation, it looks at the model that I got from here, and it says like, this is the output that I should be using. With time?
If it's an SED-ML model, right, the time doesn't, it sort of implies.
Yes, yeah. And this is all, like if you just use the string time, then like the background knows what it means. I mean, you could make it more explicit if you wanted to. Yeah.
That's why I was wondering about it.
It comes from the fact that you know what's going on. Oh, and however, yeah, that's an interesting question though, because you would need to be able to set the selection list differently if you wanted to, like, if you wanted to use the same model on a uniform time course versus a steady state, right? So you could then go in and just set the simulation selection list to only be those two things. Yeah.
What does that time mean?
Well, you wouldn't use it, right? I mean, like this is what that's what the simulator will need, right? So SED-ML is sort of agnostic on it. It just says like, if you're going to collect some of the data, this is what it will, for this, in this case, this is what you would need, yeah.
Different scripts might need different selection lists for one.
Oh, for different, for a single model.
Yeah.
You can set, so you can change the model and you can set the selection list at any time. So if you want to like reset the selection list, you can do that. Mm-hmm. Yeah. Yeah. So you could do that. Yeah, again, you could make. I'll get into that in a little bit, but yes. Yeah. Then in the script somewhere. It is a property of the model, and you can change anything in the property of the model. I think I see it as a property of the model, so I put it in the model. It could be put elsewhere, and it can be set elsewhere also. I don't think I have any specific examples on that, but like here, you could. So like, oops. Anyway, so like you can imagine in your script form, sim1 equals this, and then you like say mod1 dot set selection list, a new string, then sim2 equals simulate, and it collects new data. Right. Yeah, yeah, exactly. Yeah. And all these things are optional. I mean, so technically, here, let me see here. Again, I sort of wanted to start with just the basic ideas, but I'm going to get into like what specifically I imagine the model to be, but yeah. Yep, exactly. This is what it would look like in XML. So this would be the actual SED-ML file. I'm sure you can all read this. Yes, definitely. So we've been talking about models. Let me tell you about models. The basics are the same. And now I have a selection list to define the output. Model changes are now themselves a script. So let me see here. So in current SED-ML, if I can load a model from a file, and then I can, in SED-ML itself, I can say, change that model to be a slightly different model. That could be as simple as like set this parameter to be 5 instead of 4. It could be as complicated as remove this reaction or add a new reaction or add 3 more species or whatever. The mechanics of doing that are really complicated in SED-ML, so very few people or very few interpreters let you actually do that. So the capacity has been in SED-ML for quite some time, but not a lot of people have made use of that because it's too complicated or it's too awkward or something. Yeah.
They make a model change, and you want a simple, they go back to the previous one.
Yes. Where is? Yeah. So reset is basically my work for that, right? So one of the things I imagine. Yeah, snapshot. You can. An easy thing you can do. Did I say like they can be copied? Oh yeah, my last thing here. They can be copied. So if you just copy it, you clone it, and then you can just keep it in that state to use it. Yeah, you can go back to that version of it later. So yes, so model changes. when you load a model, you may want it in a different, to change a few things. Those things are, there is another class that I call model change that we also have in current SED-ML that is like set something, change something, whatever. Now, when you load a model, if you want to always use it from a particular initialization state, you can then run that sort of initialization script, and then globally, that's what that model will look like when you use it in any of your other scripts. But those model changes can be, you can call a model change inside your workflow script also if you want. The models now explicitly exist in these scripts as an object with a state. So one of the things that's sort of unclear in SED-ML as it currently stands is that when you simulate a model, typically when you're done, the model is in a new state than it was originally. Like all the values are their final values, and time is now different or whatever. So now I would like to say that models explicitly have a state that can be set, can be changed, it can be read. It can be, so you can query the current state of the model, you can read it, anything else.
What do you define as selection list or everything?
Everything. So yeah, the state is everything. The selection list is just what is output. Yeah, and this is when I was talking about being reset to the post. So the model object is defined and has the list of changes, and that's sort of its initialization state for all the other scripts, and you can reset it to that. Or you can copy it if you want to make further changes and things like that. Yeah. Sure, yeah. Yes, I don't know if I have anything specifically that talks about that, but that is definitely compatible with this proposal. Yeah. So here's my first lovely UML diagram. It's like, oh, let's leave. Basically, it's the same. The selection list is new, and now the changes are now just a change script, which is a script itself. And you can technically run anything you like. The only thing that might be different is the scope of what variables mean in that area. We've mentioned this a little bit. For changing a model, there's 4 basic things you can do. You can set something, you can add something, you can remove something, and you can reset it. And resetting probably then means you can reset things to undo the adds and removes as well. I wanted to try to get away from this XML-centric way of doing things, so there's no XPaths, it's just semantic. So if you want to delete S1, you say quote S1, and then your interpreter is supposed to understand what that means. Reset back to the end of the initialization step. So when you load, it's loaded here, yeah. So anything in this script is run when you load the model, and then at the end of that script, that's its initialization state. Anything you want, if you don't want that, then just don't put in the script. If you want it just as it's loaded from the file, it goes back to the end of this script. At the end of the change script. So if I have one model and it's just as loaded from the file, and another model, I load it from a file and set S1 to 5, then if I reset the second model, S1 will be 5. But if I reset that second model, but if I reset this model, it would be just as loaded from the file itself. Again, this is my ideas. We can do whatever we like, but yeah. So saying that there's no XPaths and it's just semantic, I'm pushing the burden of that meaning onto the model formats. So each model format would have to say what a given string means to that format. And I'll talk a little bit more about that in a bit. And these changes, again, can appear in any script, not just the model change script. So I can load a model and change things in it immediately, and then that's used out everywhere. Or in a actual workflow script, I can change a thing and reset it or anything else like that. In fact, resets are probably only going to be useful in the context of a work script as opposed to a change script. I can imagine also resetting in general resets everything that's global initial state, but you could say, but I put in something so that you can ignore particular things that's like or only reset this, don't reset the others. One thing that Herbert likes to do is reset the species values, but nothing else. Like everything else stays the same, but now my species values are what they were originally, even if my parameter values have changed in my SED-ML model or something. Or maybe I've added a reaction and I don't want to undo that. I want to leave the reaction in, but I do want to reset all the values to what they were before that. Dun-dun. UML, break time. Here's so set is just, I have a model. So let me see here. The way this, so the command is the general, like it is an element of the script. And one of the commands is change the model. I can set the model with, I have my model, I have my target in the model, and then the value that I want to set it to. And I just have it as a string because there's all sorts of things, it doesn't have to be a number. If I want to set something that's Boolean to true or false, then you can set that there. Add a new thing. It's just a string. Again, I'm pushing all the burden of what that's going to mean to the model itself, to the model interpretation. And that's something that SED-ML can define for particular model formats. But in general, if we want to be open to a variety of model formats that might encode things in a huge variety of ways, all I can think of as far as SED-ML goes is just say, it's a string, off you go. If it is math, if you want to set something to a mathematical, I mean, if you want to calculate what you want to set your value to, then you can, if you don't want to use the value, then you can use the math and it can calculate something and set it to that. Yeah. Yeah. Okay.
So I'm a bit confused, maybe semantically. So for me, SED-ML is a set describing in silico experiment having just one model. Am I wrong?
That is typically what it is used for, but you don't have to only have one model. You could have multiple models. You could be comparing two models and say like, I could have two models and a data set, and I could run an experiment to say like, run this model and compare it to the data set, and run the second model and compare it to the same data set and see which one is better and report which one was better or something. Yes.
And the model, which is like you have to do any reaction or you get a species. For me, it's already the same model.
Absolutely, yeah.
Not scientific.
Yeah.
Yeah, and this is, I mean, the type one model is how you think the whole model. And you change variables to data and you change parameter values.
Yeah.
And more than one model means how they, okay. So in one set, now they could be more than one model or just variation.
Yes, you could do both. You could definitely have multiple models. And again, I agree, like the semantics of what a model is, if you're adding a reaction, most people would probably say like, that's just a new model. And in SED-ML, in a script, I mean, it might be useful to think of it. Yeah, let me go back to my, or here. So here's an example, right? So mod 1 is this model, right? I loaded in, it's an SED-ML model I loaded from 2000, which is a zombie apocalypse model. And I set a value now to a new, I set an initialization to a new thing. But then I also change the stoichiometry of a reaction to something new. Now that's a new model, right? And so as far as the script goes, at this point, my new model is just a local variable called mod1, and I can do that with that what I want. If I wanted to report that, if I wanted to sort of publish that, I should know that I've changed it, certainly, and I might want to like write out the new version of the model so I can say like, this is the model that I'm actually using in the end or something. But I have created a model. I mean, you can imagine like creating a model from scratch using these things. Like I load like an empty model, add a bunch of reactions and species, like, and you could imagine like creating a whole thing from scratch and like building the whole thing, maybe perhaps based on external data, perhaps based on something else. And then if you wanted to publish it, you would need to know like what part in the script was I done like messing with the actual model itself. Does that help?
A good example the personalized model. They often have like a generic model, and then they have like data from a lot of subjects, and then they create variants of the one model to different subjects. So this personalization normally, in my opinion, couldn't publish them 1,000 different models for every patient, but you could have one generic model plus the instruction how you personalize. I think this is a good example for. How do you if we have one model or 1,000 models?
How do you utilize if you have, like, 10 patients?
Like, with this strategy, it will look very lean. You will have a small archive because you only have to report the changes to your generic model. In the case you import every model, you have to program that the data is just exploded. A good example is if you go to biomodels, there one group uploaded 10,000 whole genome models, which are basically just changing 2 or 3 parameters for every patient, but they have like 10,000 whole genome models on biomodels. And in my opinion, this doesn't make sense because it's a lot of sophisticated data, which you could store much easier by just recording the changes.
That you made, yeah. Yeah.
One question to that last. So you have that math element there.
Yes.
And what would be allowed to be in there? Like if you needed stuff from other model elements. I mean, that's the reason why SED-ML was getting so complicated as it was in the last.
Yeah.
Because suddenly you had like variables that could come from other models to compute a new initial value.
Right, right. Obviously, this can be. We could talk about what the scope is for each thing. I think so. In my initial vision, I was imagining that the scope for a model change that was a child of a model, like in a model script, the only global variables would be the model itself. And if you wanted to initialize it from external data, then you would do that in a script for which, and the script would have access to global. The script's global objects are all your external data, all your models, all everything. So anytime you wanted to sort of use one model to initialize a second, you would do that in a script. But again, all you would have to do is sort of add something and sort of a depends on line or something to say to pull in something else that was from depends on this external data, depends on this other model that would pull it in.
I guess I'm just waiting until we get to some more examples, whether the see whether XML is the right.
Yeah. Right.
That's funny, you have XML the other day. Correct me if I'm wrong, the group of problems before they have to edit the XML directly. You have to write actually in XML. There's still a lot of confusion up there. So
Yeah.
you see the XML, they're horrified.
Right, they do. Yeah, again, the XML, it was always right. Right. So if you like, this would be out of like, don't worry about the XML, just variable, use this sort of format, right? So yes, ideally, if we did store SED-ML as XML, you would want an interpreter for you that would understand what it is and like translate back and forth and right. But yes, yeah. And there's not always the right tool that would do that. Like right now, like we're trying to do some SED-ML curation, and there's SED-ML. Like so, the other day I took some SED-ML from biomodels, right? And I was trying to reproduce a figure, and the biomodel says like it had most of the information correct, and it said like make a figure with these curves in it. But in the original, and it just plotted everything. And so if you run that, it produces a single plot with all the curves on that single plot. But if you go look at the original figure from the paper, it's one of those things where each curve is on its own subplot. So the scale is different because it's completely different. So you have like one thing here, another thing here, another thing here, another thing here. So in order to edit that, there's no SED-ML editor that currently exists that lets me sort of pull that out. I had to go into the SED-ML itself, and because I know XML, I'm like, all right, here's my child 4 scripts, and here in a single plot, I'm gonna copy that 4 times, and then leave exactly one curve in each one, and then it all worked. Yeah.
Figure is such importance, how much you want to have something that allows you, if you wanted to take that result and draw it yourself with whatever program you want.
It's a good question. And in general, my hope has been that SED-ML would be able to give you all the semantic information you needed. And it might give you a red line that instead of blue. SED-ML lets you say if it's red or blue right now, because we added in a bunch of stuff with level 1 version 4. But like I think I still think I would like a SED-ML file if you naively just run it and it gives you something to look at, and you then pull up the paper, it should look basically the same. Like maybe the ratios are a little off, maybe the colors are different, but I should be able to look at them and compare them and say like, that's the same figure, right? That's what I would like out of SED-ML.
Specialize on the visualization, other things specialize on the simulation, doing the whole log part, and then you would at least rather do for maybe the whole visualization. You don't have to re-implement it, but there's probably one or two tools you can create, like dynamic graph and static plot and so on. And you just couple them to your simulator to do the simulation.
Yeah.
Being modular, not everybody has to do everything. You just have to be clear of what everybody can do.
Right. I've mentioned a few times, individual model formats assign their own semantics. As an example, this is what SED-ML could do. So you could use sort of dot semantics and say like, just an ID of something is just S1. If I had a submodel, I could say, if mod1 is the ID of my submodel, I could say mod1 dot S1, and that would be S1 in the submodel. SED-ML could use a similar format for this. There's also local variables. If J0 is a reaction, and K1 is called a local parameter on whose scope is just that reaction, you can mention it by that. You could call element attributes S1 dot boundary. And that would be that's a Boolean attribute that says whether S1 is a boundary condition, boundary species or not. If E1 is an event, Events have delays. You could just say E1 dot delay. Or you could do a variety of things. So like J0 dot K1 dot constant. It means like the constant flag on the K1 thing of the J0 reaction. Yeah.
Another thing you have multiple models. Qualify the ID model.
Yes, I mean, like, so for model changes, you already know which model you're working with, but in general, yes. Like if you wanted to say, yeah, if you're comparing, yeah. And so, yes, I think like in the math ML or something, if you're say, yeah, mod1.s1 or something is definitely a thing. You could do that too. Model remove, if you want to take, oh, sorry, yeah. Mm-hmm. Is if there's a different way to do it, I'll be happy. Yeah, is there, or like you could use like key value. So one thing about like mod 1 is that it's only going to have so mod 1, if it's a submodel, it will have elements. S1, if S1 is a species, it won't have sub-elements. It'll only have attributes or something, right? E1 is an event. It's only the only things it could possibly have as children of it are those sorts of things. Yeah, but mm-hmm. Yeah, well, and again, the scope, it is a string, and each modeling language can define what the strings mean, right? If there's some way, like SED-ML can probably use dot semantics. Maybe there are other things that can't, or maybe other things that want to use something, some sort of combination. Like if it's an event, it uses a hash symbol, dot hash boundary or something for attributes, or I don't know. There will probably be a way to refer that people typically use it. Yeah. 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 And like, and even this wouldn't work always. Like you can imagine, like there would be some actual attribute of mod 1 and also a child element with the same name as that attribute, and then there's no way to distinguish between the two of them. It was probably a good idea to not make your model that way because it's confusing. But if you had to, like, would there be a way that you could distinguish between them? And I don't know if there's a good way. We will have to sort of hash that out, but yeah. Yeah, the arrow could work, like a dash greater than, yeah. Or colon or something. Anything that, symbols that you can't use in your IDs is the main thing, or quotes or something, yeah. 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 Let's see here, model removes. Removing, yeah, go ahead. Yeah. Yeah, you would. Or your interpreter would have to, or something would have to say like, yeah. And it's not part of SED-ML. It's not part of, it would be part of each model standards. Each individual model would say like what they would need to use. I mean, you could have best practices. You could list what SVML does. You could list what SED-ML does. It doesn't. Right. Just strings.
The dimensions, the data types are of the same.
Yeah.
I think that there's a bigger problem. I could imagine that we have like just a lookup table that a list when we define the symbols of the model, and then we say, okay, this is our SED-ML internal ID to access it, and then we have the model language specific hashtags and whatever.
Yeah.
And the definition what the dimensions and the data types are. But somewhere it has to be defined somewhere to tell you about it.
Yeah. Yeah, it has to be defined somewhere. Yeah. Yes. So as far once there are results, the selection list is that what would be used for that. But yeah. Oh, Oh, okay. I could. So yeah, like ports basically. Yeah, I could see that. Yeah. Mm-hmm. All right. Let's see here. So if you want to remove something from a model, that's probably relatively straightforward. It probably has an ID, and you can just say like remove the thing with that ID. If it doesn't have an ID, maybe it has a meta ID. You could use that. I could imagine something like if I want to remove the second product from the third reaction of the model, you could use some format like that. Yes, sorry, you're right. Right. Well, I mean, like, yes, you would have to be able to say, like, how do I access elements of MATLAB, right? Yeah, MATLAB isn't going to have reactions, but it will have variables, and yeah, and then the math, and you would have to say, I don't know, you'd have to define like how to change things, and some, like if it was MATLAB, you're probably not going to be able to change anything or add anything or remove anything, right? It's just going to be like this is the MATLAB thing. What? You could have a MATLAB script as your external thing. It would be obnoxious, but you could do it. Adding something to the model is a lot more complicated. You could imagine, like, so antimony defines a reaction in this sort of string. You could imagine using that. You could use literal XML if it was actual XML. You could use something YAML-like. You could have a list with defined parts. So you could say like a reaction, if I want to add a reaction, I add it like this. I use the word reaction, and then I give it an ID, reactants, products, kinetic law, whether it's reversible or not. That sort of thing. So again, this would be model specific, model language specific. Right now, yeah. Mm-hmm. Yeah.
And I think that at least for Python, my kind is way easier to put YAML file than XML file. I feel like the ecosystem together coming up is easier to work with.
Okay. Yeah. Yeah. Way more than XML. I mean, I can edit raw XML. Right. Yeah. The last digit. Yeah. That's right.
I think it's more
I would think so. Yeah. I mean, the difference between XML and YAML, for me, isn't that huge at this point. But yeah, the only XML can be wider and YAML is going to be taller, basically, right? So, but yeah, but you don't have fewer angle brackets in YAML. One thing that sometimes confuses me in YAML is when you have multi-line things, like the indenting. It can be awkward, but anyway, but you can get around these sorts of things. It's all solvable. Oh, yeah. So I talked about this a little bit more. Here's a script form of a model change example as a script. I define my model and then I set a couple things, and including a particular, like the stoichiometry of a particular reaction. Let's see here. So yes, so this is the model change example in the script form, and here it is in YAML form. Yeah, so we should definitely, but you can imagine, but again, like hopefully your interpreter will be able to like pull in this file and give you this, or pull in your I didn't have an XML version, but pull in the XML version of this and give you this, or whatever. It can be a problem trying to go from this to SED-ML, or like having this be your standard, because like this is like Python as opposed to it being like a universal thing. But if you store it like this, then translating it to Python should be relatively straightforward. External data. External data in my version is just a data description, which is from current SED-ML. I booted the NUML part, and but then you need something. I should describe things. Okay. In current SED-ML, data descriptions have use something called NUML to define what the dimensions of the data are. And it's a little awkward, but it's complete and it works. So those are the two conflicting things. I would like to get rid of the NUML part. I don't think we have to have it. And I think there are some data formats out there that don't need it anyway. Like HDF5 basically comes with its own description of its dimensions. A CSV file, all you need to do is say like, it has a header row, it doesn't have a header row. I want the first dimension to be columns. I want the first dimension to be rows. And then you can just go from there. I think this gets to the SED-ML specific way to reference things. In SED-ML, I think we should reference things as dictionaries or arrays. Like, so if something has a header row, then you reference it by that header row. If it just is the third thing, then I can reference it by element 2, right? I think there is an old GitHub issue for SED-ML for files inside files. Like I have a Combine archive. The Combine archive has an HDF5 file in it. How do I reference that? So we need to come up with something easy that will work for that. Again, you can imagine like a dot format is like file name dot something, or I guess you wouldn't use dot because dots can be valid file names, but a list of strings or something that will get you your sub values, or a worksheet in an Excel file. Again, might be a little bit more need some thought to how to reference it. But this would be the UML version. This is basically what you need. A local ID, so you can reference it in the scripts. Here's your source, which is your file name or whatever else you like. A format, which comes from a list of possible formats, and then maybe there's a data type. This is where you would put like has header row or doesn't, or that sort of thing.
Where the indexes would go and everything that was in the
Right, right. So here's the YAML and the XML version, again, tall versus wide of external data. Yeah, relatively straightforward. Yeah.
One issue I have with current SED-ML is that you have data in very many places. Like for the computer, it's the work of the data is all the same. The problem is you have very many different ways to define it. And here it's the same with data coming from model simulation and data coming from external files. There's a lot of things which you have to be very similar. For instance, like I mentioned, you want selections on your external data, or to define a subset. And it should basically interchangeable. It shouldn't matter where the data is coming from. It should always
Yes.
be the same. And,
yeah, I think like inside the scripts, and I'll get to that in a bit, but I think if you refer, if external data and simulation data come back as dictionaries and arrays, then just everything gets treated as a dictionary or array. Yes.
can use like simulation data and should also be able to use external data.
Yeah, absolutely. I agree. User functions. So this is I'm sort of going through the global objects before I get into the scripts. I maybe should have organized it differently, but anyway, user functions are self-contained scripts. Again, I think like as I have imagined things, each user function has no global scope. It has arguments that go into it, and then it just uses those arguments, and that's it. It doesn't, like, you can't refer to a model that you defined elsewhere. If you want to refer to a model, that has to be one of your arguments. You can pass in anything you like, so go just pass it in. Required arguments, optional arguments, an optional return value, because sometimes you may just want to process a model. You may not want to like return something, but you might. This actually was like GitHub issue number 5 on the SED-ML thing. So was to have user functions. Oh yeah, is that now? Sure. So sure, let me. This is user functions. It's a list of scripts. Yeah. Go have some coffee. Thanks. All right. There we go. All right. Well, welcome back. I was talking about user functions when we left, which are basically the same as scripts, which I haven't told you about, but they're the same as them. And so you have required arguments and optional arguments. The arguments have an ID and potentially a default value. And then in the script, all the values that you can reference in the script and then have to be one of your arguments. And right now, I have an output from a script as an actual like element of the user function itself, and then you just have to sort of find that element in the script. I don't know if I like that or not. Another option would be to make a command a return command, and then it would just return whatever it is that you returned. Both are possible. Why is it? I don't know why this script. Oh well. Oh, I called it external data, but it's actually user functions. Look at that. Okay, here's it. The user function might look like something like this. Here it is in YAML. I might send it sim data, data, and like simulation data, external data, and then return the both of these are arrays, and then I just subtract them, take the sum of the squares, and return the sum of the squares as a possibility. Here it is in XML form. You could also store it like this. They would have to match, yes. You would just say they match. And again, if they don't, but they have subbits that match, you could be more explicit in your comparison thing. You could say like sim bracket this 5 is the same as data bracket 6 or something. So the script, the core of SED-ML execution. I would imagine that most SED-ML files will end up with a single script in them that you just run. But as designed, you could have multiple scripts that could be run in parallel or separately or whatever you like. You could have multiple scripts, some of which depend on other ones. And by depend on, I mean that if you run one script, whatever variables are defined at the end of that script would then be the same as the variables that are defined for a different script. So that's the scope for that. Again, part of the hope here is that we can facilitate parallelization of different stuff, different things you might want to do. Each line of a script is a command. I've been telling you about some commands earlier. And obviously, order matters, which it hasn't in SED-ML in the past. SED-ML has been declarative. Here we are like going through steps. And so that you do the first thing first, and then you do the second thing. And that's it as far as scripts go, except that you may notice that I have my script be a subclass of repeat or reproduce, which I have not told you about. So I will do that now. Because SED-ML is used both to repeat something exactly and to reproduce something anew in a different context, we might need to store that information, store information about that. And so I think if we make like a script, and also a command is also a subclass of repeat or reproduce. If we just store that information, we should be able to, you should be able to repeat something and you should be able to reproduce it. The repeat class would store hyper specifics about like, I use this particular thing, I use these particular environments. And the reproduce class would be where you would store like, I need delays, I need ODEs, I need events, or whatever that sort of thing is, general requirements, or I need a simulator, I need something that will do a plot, any of the individual things like that. And you can store this information on the SED-ML document itself. It's just like I have my SED-ML document and I store what I need to repeat it. I store what I need to reproduce the whole document. Maybe that's all I need. Maybe a particular script has that information. I can say like this script needs this particular environment. Or maybe an individual command might say like this command needs this particular thing to reproduce, this particular thing to repeat. Dun-dun-dun. So this, again, this can be adapted in the future, but the basic idea is that you would store the information about repeating or storing the information about reproducing as child objects of your elements, of your script or of your command. Say, I repeat with this, I reproduce with this other. So here is an example. So I have my command, my steady state command. I'm assigning it to a local variable. I'm using model 1. Oops. So here in my script, I am running the steady state thing, but then I also give it a child repeat with this. Roadrunner version 2.2.3 in Python on Windows 11. That's like literally what I was using when I created the SED-ML file. So if I want the exact results, that's what I would use. But I might want to reproduce it with in a particular environment. I need this steady state simulation capability. I might need to know about like there might be distrib elements in the SBML file. I mean, algorithm parameters, yes, those are separate, and yes, you could do that. And you would, I don't think you would put them here, right? The algorithm parameters are separate. I don't know if I've talked about. Yeah. I'll get the steady state in a bit, but yes. Algorithm parameters basically work like they do now. I didn't change much of that. This is a new these would be a new thing that would the algorithm parameters would still be the same. The only issue that I can imagine is that sometimes one particular environment might need a particular algorithm parameter that a different environment didn't. Like if I running a steady state in this context or with these algorithms, it might be different. I might need a particular like sensitivity with that I don't need in this other steady state program. So I don't know exactly how to deal with that other than to just have the algorithm parameters themselves sort of link to particular environments. But it's an interesting question. Yeah. Yeah, like a Docker container would be in this repeat thing here. Yeah, exactly. And maybe I don't have all the right attributes to well store like a Docker container. But I would, yeah. But yes, I would definitely want that. We'll have to figure out exactly how to store it. But yeah, yeah. Oh, like, I guess, yeah, right. I mean, like, and that's the whole point of doing this of doing it in the first place. If I want to repeat it exactly, I do this. If I don't have access to it, then you have to figure out. Yeah. Right. And that's what we would like to avoid in SED-ML in general, but something like this would at least give you the hint about like if I wanted to do it exactly. Yeah.
Now you sort of mentioned you have a particular execution that SED-ML inside of SED-ML itself, rather than saying I ran it SED-ML on the fire. So this is all sort of make an interface up.
Oh, like if you, yeah.
Like if you want to base a particular defined you ran.
Right. In the SED-ML file itself. The one particular use case I thought of was that if you are comparing simulators, then your SED-ML file is set up to compare two simulators, and you would have to have some sort of specific. I use this simulator here, and I use a different simulator for Sim2 or something, right? I don't know. Even there though, I don't know if that's necessarily the right way to do it, because I might want to say just like use a different simulator for this, and this is a way to compare them, whatever they are. It is. I share your like. And I think if you want, yeah. Yeah. Oh, like the CVOD from Roadrunner would be a child thing or something. Yeah. But would you want a Casal term for every different version of Roadrunner? Like if you wanted to record? Yeah. Okay.
That would mean that, like, okay, I'm describing what has to be executed with what parameters and what output in SED-ML. I'm describing outside. I would just have been actually one place and then another. So the outside script that could be YAML based could be outside stuff.
Yeah, I could see that also. The other thing though is that you sometimes need to be SED-ML needs to be a modular. Like you might need to run like even if it's just like the run a simulation and the plot the results are two different things, right? But
This said now that with
mhm.
all the private sites, you grab components that set it out.
Yeah, yeah. It's a it's an interesting question, and I don't know if it necessarily should store everything here, or I feel it would be nice, and like if there's a standardized way to store it, people are more likely to store it. Yeah. Yeah. It's a meta annotation-y thing. Yeah. I could see that. Yeah. I do think the reproduce bit is useful in SED-ML itself. If you list the capabilities you need, then you don't have to like look into the file and stuff. But a summary of what the model, yeah. Mm-hmm.
And then you have the future, which just which tools are used to
Yeah. But if you, if you're just worrying about the capabilities, yeah. Yeah. So yeah, the repeat with may belong somewhere else, and the reproduce with may belong in here. I could see something like that. All right. Commands. All right. Again, this is the core of SED-ML in the new version that I'm proposing. I generally split it up into generic commands and SED-ML specific commands. There has been some thoughts, like from the Jonathan Carr side of things, that we should be more generic all the time, like only do generic things and never do something more specific. In my estimation, you're more likely to get support for particular things if you call them out with specific constructs. So like the simulations that SED-ML defines, do a uniform time course, run a steady state. If you have those baked into your system, then an interpreter knows more cleanly that that's sort of what you expect to see in those things. Whereas if all you have are these genetic Casal terms, you might sort of say like there's like 500 things in Casal. Like I'm going to support some random subset, but I don't know what people are necessarily going to use commonly or not. So I like the idea of having both, and I've done that before. I don't know if it's necessarily the best, but that would be my proposal. Yeah, absolutely.
One remaining area where there is an overlap between the concepts and SED-ML, because uniform time course means uniform output, not uniform function. Why do I have output related
term in the input?
Term or requirement in the actual execution.
Yeah. Not a uniform. Okay, yeah. So yes, like now would be the time to change those names, right? If we decide like I don't like the name, like now is the time to change it. It's a new version, yeah. Right. Well, we do want to define something about the output in the SED-ML, right? Yeah. Okay. No, that's okay. That's good. So yeah, generically, if there's like a math that you want to run, like some sort of calculation that needs to be done, there should be a way to generally do some sort of math. If you want Casal, and I haven't told you about Casal yet, but Casal is the kinetic simulation and algorithm ontology, I think. And they are a list of algorithms and algorithm parameters, an ontology of algorithms and algorithm parameters that you may want to use. And since the SED-ML community took over Casal, it's now like actually like a subset of the SED-ML GitHub branch. We can update that much more quickly than we can produce a new version of SED-ML. So if you want a new algorithm that is not defined in SED-ML itself, you can instead define a new Casal term, and then you can use SED-ML to define how to run that algorithm. And it's a quicker turnover time. However, it does mean that if your SED-ML interpreter needs to be updated more frequently, because the Casal terms may be updated, and it's like, oh, now there's a new term that I could handle, and I just need to go back and make sure I'm updated with that. So I'm going to go into more detail on each of these. This is so the execute math. You assign it to a variable local to the script, and here's the math child. Execute Casal. Here's my Casal term. I assign it to a local variable local to the script. And then I have child Casal parameters that themselves can have child Casal parameters to define an algorithm entirely using the Casal ontology. Say that again?
The command itself is not only arguments.
Yes. So, well, no, the arguments would have to be algorithm parameters, actually. So like if you wanted to say generically, like a steady state simulation, you would need to have, so if your Casal thing was a steady state simulation, it would need to have a child Casal parameter that was the model that I am running to steady state. And then it would have a value of the local variable of the model name. They are local, like the local variables in the script. Or yeah, the local variables from that script and the global variables in the document. Execute external. I wasn't sure about that, but then I went back and looked at some of the things that we've talked about in the past, and people definitely want to be able to execute external scripts. It's the least nice part of this proposal, but it seems to me to be sort of like a necessary evil. People are going to want to run something specific, or they want to run something outside the scope of SED-ML, like Vega, to get like highly detailed information about the plots that you want to produce or something. And then here's all information. These are commands that are specific to this version of SED-ML, like conditionals and loops, and then change model, which we've talked about, simulate, which we've talked about somewhat, and output, which we haven't yet. And then I didn't do anything more than just say like maybe we should have an assert or an error command. But if we did, that's where it would be. So the generic commands: execute math, runs some math, possibly stores the result somewhere. Model elements are accessible with some sort of x.y syntax, mod1.s1, anything like that. Data elements are accessible with a dictionary or index syntax. Data elements would be the results of simulations and external data. You'd treat them the same way. So an example script would be like, I have my S total, and it is mod1.s1 plus mod1.s2 plus mod1.s3. And that's add up all the S's. I might want to say the error is sim1, the results of the simulation, and reference it by a dictionary, like the S1 data from that. minus the data, my external data, bracket, again, dictionary syntax with S1 squared. That I just run that math line and then and calculate the results. Or I want to say, like, over the course of my simulation one, the S1 data ended at 100, but it started at 0, and I want to see how far it changed over the course of that time course simulation. Yeah.
In the end, you have to work now with data matrices and data cubes and some nice ways for the indexing.
Yeah. Right. So I would hope that something like this, if you just keep on tagging with more brackets to get the sub things.
Also, that's what I determining generated name, to be replaced by some.
Yeah. Yes, it could be a local variable name. It could be something you read in from an external data or something. Yeah.
No, I was thinking there would be a variable called time.
Yeah. Oh, therefore you for free. Okay. Yeah, like in Python, what you would do is like you would say -1 in that, and that's the last thing, right? What? Okay.
Basically, you give your dimensions name, then you can use this name to access the data. You just say, okay, where my dimension, the second dimension, dimension has the name and change in parameter. You would just use this for
accessing the elements of the data. Yeah.
And you think that based on that, for instance, my time dimension is smaller than that.
Okay. Here it is in YAML and XML. Again, we just sort of have the math that is this. In XML, you'd have it in MathML format, which is, I mean, we have interpreters for MathML and infix converters to and from. If you did it in YAML, you could do sort of the same sort of a plus object with child, like, you apply the plus to mod1.s1. Oops, I didn't change the names, but anyway, S1 plus S2 plus S3. So I don't necessarily know what you would want in YAML, because I think the easiest way to edit it by hand would be to have infix that you just type. But if it's meant to be writable by humans, then yeah, you just want to do it in infix, right? Yeah. It's going to be awkward if you try, but yeah. All right, Casal. Casal is useful for simulations not explicitly defined elsewhere, like qual simulations or other things. Other things that the biosimulations group has been working on adding recently. There's a lot of stuff in current SED-ML that is the variable construct that would sort of be pulled into this Casal term. We have a variable construct that you can use to get the Jacobian of this model, say. And you would now just say that this is an execute Casal thing. I have my variable, I have my, like calculate the Jacobian is your root thing, and then your variable parameters are of this model, of this whatever. Calculate the elasticities, calculate the specific elasticity, anything like that. I'm not sure about particular math functions that we moved into the variable construct in SED-ML Level 1 version 4, average, max, min. I could imagine those either moving to MathML or moving to Casal. And I don't know which one is going to be simpler or more what people are going to want to do more likely. It's sort of the current way we do it in L1v4 is sort of a hack. It works. I hope. I don't know if anyone's actually like tried to do these things in the one before yet. It seems like it should work at least, and I don't necessarily know how best to translate that into a script form. But it seems like either sticking with Casal terms or moving to MathML/math in general should work. You can't just say, give me the average of this 3-dimensional matrix, because maybe you want the average of all values and you want it as a double, or maybe you want a single matrix that is like the average of all of the 3rd dimension, or maybe you want the average from the 3rd dimension and the 2nd dimension, but you want an array or something. Or same thing with max, min. Those are questions that are not obvious from just saying max. So you need some way to encode that. And it's obvious how to do it in Casal, it's less obvious how to do it in math or in infix. Here's an example of what it would look like for an execute Casal thing. I have a Casal term, it's Casal 168, and then Casal term 520, it gives a value of 3.3. Casal value of 24, the value is mod 1. It's apparently the thing that references the model. Casal value 21 is true. Casal value 900 is mod 1.s1. Like, this is not at all clear what's going on, but it's precise in what's going on because they're all the Casal terms are defined somewhere, just not in this file. Execute external would be if SED-ML is giving up, you're like, I can't describe this in I can't use Casal, I can't use math, I can't use any predefined thing. I'm gonna have to punt. Anything that's an obscure simulation, anything that's a proprietary simulation or analysis. I want to do something that is actually dependent on the particular environment. Like I'm running this only works in Python. On Windows, I have to run MATLAB to do this. Anything that's generally, it's not encodable in Casal or MathML or something, or again, considered out of scope, such as fancy plots. And best practices, you would never use this, but sometimes you may have to. And actually best practices for the fancy plots might include this. And anything that was the last term here, anything that's out of scope, that would be the only way to encode it in the SED-ML file. Yes, that's a good question. Like, what are the inputs? Like, somehow, yeah, I don't know how you get the local variables to that external script, right? You would have to have some way of saying, like, in each one would be different. Like, the Vega was going to be different from MATLAB, is going to be different from like a batch file on Windows or something. So yeah, that's true. Yeah, yeah. Yeah, that's probably okay. Yeah. Yeah, that seems reasonable. All right. Yes, we do. We do run that risk. Yup. Basically, because yeah, you could just put your whole thing in here and be like, oh, it's all Python. Here's just I am wrapping up my Python script in SED-ML, and now I have encoded it in SED-ML. It's like, no, you did not, because you just left it as Python. But so yes, you are running that risk, I would say. Right, exactly. And I think we're gonna have to let if we want people to do some things, we're gonna have to let people do dumb things. That's right. Words of wisdom, yeah. Yeah. But at least something is, yeah. Yeah, it's true. It may be better than just doing that one. Right. Yeah.
Yeah.
It's there and not
Yeah.
I mean, the other argument is saying when the work is done.
Yeah.
Lower down to.
Yeah, that's actually true. Like anything that's that has any external bits is then, I mean, unless, I mean, if it's Vega that itself is sort of a separate thing, or if it's PE tab, say, like I have my external file is PE tab, then it is as reproducible as those things are, and not necessarily it's only repeatable, not only repeatable, but yeah. Yeah. And that's actually, that would be a use for the repeat with construct, is like, here's an external command and this is what you need for it, right? This is because it's a, yeah, it's also execute external is a command, and it's a child of, it also inherits from repeat or reproduce with. So.
Yeah, you could bring them into meetings, and then when we get time credibility, find out very yeah, so well, that's probably going to
Yeah. So yeah, like in YAML, this is how this might look. You say like, I'm executing external, it's Vega, and here it is. Again, like what those local variables are is a question, and it would have to be answered for each different external language. Right, out of the script, out of the local variables of the script. Right, exactly. Yeah, anything that's like 20, like all these things, 28, 91, 19, you would want sim1 dot end or something, right? Or right. Like, how are you going to connect those two things? Yeah, I do not know. That's a good question. Yeah. All right. Things that are actually like scripting sort of things, like if-else blocks, for loops, while loops. We're going to have to define these in SED-ML itself. All of these things are going to contain math plus a child script. Like if this, which is this conditional, then run the subscript basically. The scope is then private. For the things that are external are still local, but things that it defines would not be global or global to the script. I would assume, unless we change our mind and want it to be different. Different scripting languages have different philosophies on these things, and we'll just have to pick our philosophy and go with it. I would say that what we want, our choices should be based on wanting to translate this to a variety of other languages. So we wouldn't want to say, it makes most sense to have a private scope for local variables, because then if you translate it to another language that has private scope for local variables, then it will continue to work. Whereas if you took the other possibility and says if you could define something in a for loop, it's still defined outside of that for loop, then suddenly if you translate it to a language where that's not true, you have to add in extra stuff to make it compatible again, and that makes it more difficult. Whereas if you translate that to Python where everything is global all the time, it will still work. It just isn't quite the same. And this is also a place where you would want, in particular for the for loops, you would want to put some flag in there to say like, this can be parallelizable. And I again feel like that is a thing that is, the semantics have been worked out in various languages where you have parallelization hooks for your loops and things. So we can steal from one of them. Specifically, here is a UML diagram. I have a script. My if script has like a bunch of children ifs and then a final else. And again, this is where order matters. Like I check my first if, run the script. Otherwise, else, if the second one, run that script. Else, third else. Fine, until I get through my whole list of ifs, and then I run the else otherwise. Basic conditional logic. For a for loop, just similar for loop or a while loop, it would have a child math. The child math of a for loop could define like an array that you just iterate through, or you say start end steps, number of steps, somehow define your loop in here. And the for loop again is where you'd want your Boolean flag or parallel information, whatever you might need for that. The condition is the child's math. Yeah. I mean, yeah. Yeah, so all loops, yeah, all loops have as a child math and script, and then the while loop only needs that as your conditional. It's a little semantically iffy. I wasn't quite sure about it, but anyway, because yeah, you might want to say like my vector child as opposed to my conditional child, but technically that's all the information you need. Here's an example of a loop. I have my script, I define my loop. I give it an ID of n, and loop. I'm looping 10 times. I'm running model reset. I'm resetting my model each time. I am setting the value of S1 to n divided by 100, and then I'm running the steady state. And I am assigning that to an output ssvals bracket n. So I am looping over this 10 different times, and I'm saving it in this particular way. So this could be parallelizable. And then each different parallel thing sort of fills in the value that for its loop. Yeah, that's model set. The model set is the, that was in the first half, but yeah. But yes, there's a, yes, yeah. I think it's just a string, right? So the string, right? So the target is just a string, and then each model format has to define what strings mean. What? And the value is also a string, yeah. And you'll notice that it is also a this is math, and it is using a local variable of n. Potentially, yeah. Let me see here. Yeah, that's another interesting question. Like I would use for SED-ML, it would be whatever flag is on the. Yeah, you could use the dot syntax. For SED-ML has only substance units attribute in it. What? S1.rate? Oh, or rate of S1. Yeah, I could see all of those things being used. And you have to deal with it. Yeah, exactly. Someone has to deal with it somehow. Yeah. 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 The SED-ML, the fact that SED-ML has to deal with a wide variety of model formats means that you can't be quite as specific in its spec as you did in others. However, for SED-ML, you would absolutely want a defined list of exactly how you defined everything. So you would say for SED-ML, like here is the way you reference the rate of S1. Here is the way you reference the boundary species attribute of a species. This is how you reference a subvariable in a submodel or something. You would want all that explicitly defined somewhere. Yeah. Right. So yeah, you know the SED-ML says like this is an SBML model, and the format would be the same. Now, if you wanted, like in the specific case of SBML and SEL-ML, it would be nice if whatever we decided on for the string elements was the same, because then you could actually like swap out your model, your SBML model for your SEL-ML model, and everything would still work, and you'd have to do the least amount of changing things. Yeah. Yeah. So like whatever, like I would want most model languages to hopefully adopt the same sort of thing, and we can talk to the people in charge of each model format and the people that model with each ones to say like what's the best generic way to do this. But ultimately it would be model specific. Yeah. Oh, it doesn't, right. I mean, SBML is XML based, so it's all, yeah. Uh-huh. Right. Exactly. Yes. And current SED-ML, you have to use XPaths everywhere, and it's super obnoxious, right? Because XPaths are obnoxious. Right. So yeah, so you would want something simple and generic, but you also want everyone on the same page. And so you only have to have one interpretation. It could be, except that, I mean, I've presented it as YAML, but it doesn't have to be YAML. It could continue to be XML, actually. Yeah, like each child, where is this? Oh, I didn't give it a script child, but yes.
And the other one, where the output variable,
Right, that's a good, yes, you would probably want to declare them before the loop, I guess, but there's another example where I do that, but basically I would execute math and then assign to a variable and then just don't give it a child. And then it's just like, okay, it's an undefined variable. You have to, well, you could give it give it a math and the math is an array, or you could give it a type to say that it's an array or is a particular dimensional array. Yeah, to declare your local variables. Yeah, well, I mean, so, oh yeah, and here's this in script form would look like this. Reset the model, set S1 to n divided by 100, and then SSVals bracket n is the result of the steady state simulation. SED-ML specific commands, simulate. Not much different from the old simulation class. Our basic three are your uniform time course, your steady state, and your one step is the one thing I haven't mentioned before. One step is basically a simulation with where you only take one step as opposed to doing a number of them. Yeah, it could be, the step could be huge. It could be any, and so you might need to simulate like internally, might be a bunch of steps, but like you're like, the only difference is the result. The beginning and the end, right? Yeah. And here that your output is the final state, as opposed to like a 2-vector array or something like that. I made parameter estimation, which is another thing that we added in L1v4 as a child of the simulation class, along with the other parameter estimation things that it had. There was an algorithm child of all these things that I absorbed. I pulled it into the simulate object. Basically, that means that the algorithm had a Casal term, and I just moved the Casal term as an attribute. It still has algorithm parameter children. The generic analysis class in current SED-ML level 1B version 4, that's what got changed into the execute Casal construct here. And crucially, we have an assign to attribute that gives it a local variable name that then you can use elsewhere, and it looks like data, right? It is the result. It's the same thing as if you pull in external data, it has a name. If you simulate, it gives you a vector and it has a name, and you can do stuff with it. I think it's designed to at least solve most of the confusing repeated task problems, because now we're explicitly pulling out exactly like data in a particular form for all these things. It has precisely defined output, like a dictionary of results, and parameter estimations return just a parameter estimation object that you can then send to results, or send to your output things as like, here is an object, like do the normal thing with it. So that's a little small, but basically the generic simulate has a bunch of Casal parameters, something to assign it to, a model that you might reference, and potentially a Casal term. And then here are your basic 3: steady state, one-step, uniform time course, which we could rename if we wanted to. And then your parameter estimation things. Also, it just inherits from simulate so that you can give it a Casal term, so you can give it a repeat or reproduce with sort of thing as well if you want. That's it. Wow. Okay. Output structure is largely unchanged from before. You have plots, you have reports, you have figures, which are combinations of plots. The difference is that now your input of the output command is now local variables in the script. So I ran a simulation, I called the results sim1, then I send sim1 to an output report, and it prints those things in it. So like multi-dimensional data, you might just say like, yeah, give me the normal multi-dimensional thing data you want with that.
Then only the selection is defined on the model.
Yes, yes. That's one of the reasons why you have the selection list, is so that you can define these sorts of things. Yes.
So then could be overwritten in the simulation method. So
if you wanted something different, yes. If you wanted something different, you like whatever the model. Okay. The semantics would be, you define a model, it has a simulation list. And maybe if it doesn't have a simulation list, there's a default type of thing that's a simulation list. We can decide if we want to allow default simulation lists or not, selection lists, sorry. Then if you run a simulation, then the sim1 object that you get out of that, the assign to bit, then is a dictionary, and the indexes of that dictionary are the selection list. And oh, I see what you're seeing with the time thing. Like output, the time course specifically could always have time as your new first column, and then everything else different. Yeah. Okay. What? Even the one step too, yeah. So then your selection list doesn't need time in it. I think you're right. Correct. But you would know that would be defined by the algorithm parameters, I think, of the simulation, of your units. And your units would be defined by the model. So anyway, yeah. For simulation output, you would. Okay. Yeah. That's true. So the question is just like, do you automatically say for the uniform time course simulation in SED-ML, we just have to, we have to precisely define what the output is. And yeah. So you'd have to a way of tagging. I mean, you could also just say, like, you get the result and it is the result, and then you just never use that column in anything later. Yeah. So if you wanted a subset of the selection list, then I think you would change the selection list. You would say model 1, you would change the selection list before you ran your simulation.
Yeah, from one time to simulation and one plot plus the time course and another the base plot.
Oh yeah. Yes. So and then you just do your normal math tricks, right? Say like you have an object that is a dictionary, and you can either refer to the whole thing or you can refer to some things. And I will show you how to do that. Yeah, exactly. So yes. Is there anything else that I missed on this source attribute? Go for it. Yes. So you could move the selection list basically to this question instead, to the simulation. Yeah, here, like where to put it, yeah. Yeah, so basically you're saying like instead of defining it in the model, you would define it in your, when you run steady state, you would say selection list is this, like as part of your steady state call directly. So yeah. Ah, okay, yeah. Yes. I think we all agree that it's definitely specific information. We need to store it. I don't think like in a forward scripting language, you would need to define it at least at this level. I don't think you can wait until you get to the output.
But for example, that are really big, and you don't want to do them several times. You do them once and then extract the different outputs once.
Yeah. But you still need to tell it which output you need, don't it? Don't you? Like you don't want to run it again, but you do need something that has all the output in it.
The simulator will not bother storing the other data. So if you've got 100 variables in model and only want 3 of them, I'll tell the simulator, don't bother storing the other 97. Just store the 3. So when the original start backwards, it's not matched. Well, you might be talking about some massive arrays. It's going to be something Python or some other language. You want to give it some kind of hints for optimization question.
But that's only relevant when you have stuff that's local. When you're running the distributed simulation, you generate data, and it's just irrelevant. You have to deal with that.
And then you say, I mean, you don't do selection.
Yeah, but you can tell it. So again, my I don't want to have a default. No matter what it is. Oh, what I need.
So yeah, if you, yeah, I.
But if it's 100 variable thing, then I can write down.
And if you don't, you only run the default.
No, he said he didn't want any defaults, right?
Yeah, so nothing is written down, what do you get back?
Nothing. Well, no, and that's actually good because sometimes you. I could imagine saying like having ways to say the selection list is the species or all floating species or ways of saying of sets of things. Yeah. 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 Some way of saying like, give me all the species, give me all the fluxes. Yeah, give me all something. Right. I think that's all compatible with this sort of thing. Data-centric view. Pipeline.
And then you can, if we are able to track how various are defined and how they can be used, and you can select what actually requires.
And you don't think you can do things that way? You think it won't work with the selection list, or you think? Okay. Yeah.
Essentially, everything you use the you have X, Y, Z, variable, and parameter.
Okay.
So you do a parameter scan over this time window, and it's just simple, like indexing of the dimensional matrix that you should be able to specify. And then you extract everything at this time point for these variables, or any other combination thereof. So and this has been standard fare where the number of visualization programs, slicing and dicing the data.
Yeah, and I think that was my intent with what this is, right? Let me see if I can find. This sort of thing, right? You can use this sort of syntax in your output also, right? You can say like bracket the particular variable, the particular dimension. You could have 6 brackets for your 6-dimensional data, and just reference it that way. And you could reference that for the internally for like I want to use this to parameterize this other, but you can also use it for the output. I want this dimension. Like if I just say sim1 bracket s1, that's what I want as in my output, and I want all of it, even if it's 6-dimensional or something. Yeah, you like put it in there. I mean, that's probably way at the beginning. Like this.
No, but now we don't just want sim1. We want sim1, we want s1 and s2.
Okay, yes, that I'm coming up to soon. Okay, simulate output. A plot looks like this. This is basically what it looks like right now. Curves and surfaces also basically what it looks like right now. The only difference is now your references are var ID refs, which can be your that sort of string with subvariables mentioned. Reports, same thing, listed data sets, figures, listed subplots. So here is a plot in YAML where you are like specifically saying, I want these but 2 things. So originally I said like, here's just sim1. If this is all that sim1 had, then you can just say like, just plot sim1. But if it had like 8 things and I only wanted 2 in this particular plot, then I might do this. Here's my figure. Here's the plot, and call it figure 3. And I have 2 curves. One, and there's sim1 bracket, there's X is sim1 bracket time, and Y is sim1 bracket susceptible. for the other one, sim1 bracket time versus sim1 bracket zombie. Yeah, I've a math step before, right? Where you could either change that variable directly or assign it to a new one. You could either, so if you have a math step, you could say, if you want to divide everything by 100, say like internally time is in seconds, but I want to report time in days, then I just say like, then I just process the time vector and say sim1 bracket time equals sim1 bracket time divided by 60,000 or something. Yeah. And this is what it would look like in XML. It's the same thing. Same data, slightly different version. Oh, and this actually has the whole, like the model and the script and everything. So this is the full thing. I define, this is again, a complete SED-ML file. I define a model, give it a selection list. Here's my scripts. Here's my uniform time course. And then I have my plot that I'm plotting two particular curves from the output data in. Some things that I haven't talked about. Interpolation of data is something that we need a way to describe. That was SED-ML issue. Could be, yes, it could be a math step. It could be a math step or a Casal term, basically. And yeah, either one would be possible. Or it could be something with the simulation itself, perhaps. Well, I guess the simulation itself would probably do just, you would not tell it to collect the particular data points, and you would just say like collect the output, and then another step to process it to interpolate to particular values. Or you could have it as part of the simulation itself. I can imagine there being a use case for asserts or errors or warnings. Obviously, if you're repeating something exactly, you're less likely to need it, but not entirely unlikely to need it if there's anything stochastic in your simulation. So you can just say, like, so I can imagine them being more useful if you're repeating it in new context. You say like, make sure, assert something is true because this should be true at this point. And if you're searching down problems, it makes it a little bit easier. I could imagine a return command instead of just saying like, return the variable, the local variable that is sim5 or something. I could also imagine a use for print statements, log statements, something like that. I could also imagine, again, that we could take some things that are currently Casal only and pull them into SED-ML core and say, like, there are some things that it turns out it's useful to do a qual analysis of this particular form. Let's give it SED-ML constructs instead of just making it call everything with these generic Casal terms all the time. I don't know what they've been doing, but I just know that they are doing things. So yeah, but I mean, in general, like one qual thing they do is like a reachability analysis. And so, I mean, there's going to be inputs for all of these things. And if they would like something that's a little bit more obvious from the file itself, then we can make it non-Casal by pulling it into actual into SED-ML things. Let's see here. So this was my original example that I showed you, just the most simple thing. Like, here's a model, here's a simulation, here's the plot. Here's a similar thing with it for a steady state. Again, you sort of run steady state. As Frank pointed out, the selection list is a little different here, and maybe it shouldn't be. This selection list had time in it, and this selection list doesn't. And it might be that you want the a uniform time course to sort of automatically give you a new column with time in it. Oh, I define it. It is this. So you define it in the spec, and you say it is a dictionary with a single value of whatever the selection list is. Instead of so the return value. So SS1 is a dictionary. So SS1 bracket susceptible is a single value of the steady state value of susceptible. SS1 bracket zombie is the steady state value of zombie at the end of the steady state.
So it's selection list would also be something like weights. So we list them.
Yeah, yeah. Right, because you might want to just run this. You might want to run the model to steady state and not produce anything, right? And in that case, yeah, you'd have an empty selection list. Sure, sure.
And there comes the point where if you want to bring your model to steady state first, then do some changes and continue, you might need a selection list afterwards.
Yeah, sure.
So how would you
Just set the selection list here. Anyway, yeah.
Don't need to know what we go.
Right. But you might want to, yeah. So it may be most useful to put the selection list in the actual, like as an argument of steady state. Oh, I've been using my mouse and it doesn't work because the mouse is over here. Mine, sorry. So yes, you might want it as an argument to steady state. You say model comma bracket susceptible zombie here. That makes the most sense. Okay. Yeah. 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 What to keep, right? Yeah. Here's our change model example. Here is a loop where, and I think I showed this earlier, or something like it. So yeah, now I'm looping Z over a range. I'm setting the zombie to that value, the particular value. I'm running a uniform time course and have results in here. Here's where I like that you were wondering, like, you defined your variable earlier is an array of size 10 as an there, and then results in there. A parameter scan example. Again, sort of loops. We have nested loops. We run things on we reset the model, set everything, set the alpha, and even set beta and zeta also. Run your uniform time course and set the results maybe to the, and here we have a script, like a subscript, like the user-defined function sum of squares that we're calling there. And I think that might be, and there's there is that Python script in YAML form, just to sort of show you that it can be done. Oh, and yeah, YAML page 1, YAML page 2, because it's really tall, right? Because the YAML is huge. And then here's your XML version, page 1, page 2 for that. And that is all my examples. So thank you for being here for that whole talk. All right. So, yeah.
My main problem is that we don't specify the data dimensions and the input and output data format.
Yes, we do. Yes, that is defined. That's what the selection lists are for. That's what so each like in the well, like the definition of the Casal term would have to say, like, it is a dimension, the Jacobian is a matrix of dimensions, number of species by number of reactions, or whatever it is, right? So that would define, it would, the Jacobian in particular would be defined that way, and you would just have to, so would you want a hint of saying, like, there are 30 species and there are 20 reactions somewhere? Like, where, if I ask for the Jacobian, how do I know that it's a 30 by 20 matrix? And the definition of a Jacobian would tell you that it's species by reactions, and the model would have species and reactions in it. Oh, sure. Yes, and and the order would be defined in the Casal term. You would define what the output is in the Casal term, I would think. Like which dimension, like it would, yeah. Yeah. Oh yeah, like the name you would want to get. So yes, you would need a Casal term for give me the species, right? And it would just give you a matrix, a vector of the species, and it would be that order. Because that's what, and then you would have a similar thing for give me the reaction names, like basically gets, yeah, it would be a Casal term or something specified in SED-ML that is give me the species, give me the species names, give me the reaction names. I could imagine it being an input for the Casal also, like a parameter attribute, a parameter. What are they called?
Rather we want labeled arrays. Right?
Yeah. Or yeah, and it's a labeled array, so you could access it by index that way too, right? So it would be Jacobian bracket S1 bracket J0 would tell you what it is. Yeah. But yes, I would definitely want everything defined. Like I don't necessarily know where the best place is to define it, and I think my idea was that it is defined in the definition of the function.
Leave the problem for figure out what I mentioned. My multidimensional matrix has to look in 20 different places. I have to look up, I don't know, some Casal term definition, then I have to look up some loop variable, and then I have to look up what they mentioned instead, and then I have to look in 20 steps.
The loop variable is in SED-ML. That's fine, right? Ah. Okay. Here, let me.
Much more, it would be much more explicit at some point. Instead of having to look up the information everywhere. Just as good, not yet.
There? Okay, yes. So
what the measure has, what the measure has result.
Yes.
Oh yeah, I see.
One, right? Yeah, okay.
Yeah, I know that.
Well, that's why I said at the beginning that it shouldn't be clear before. That's what I mean. Like, it would be much nicer if we clearly declare the dimension of the input and output somewhere.
Yeah. I mean, yeah. So my idea is that every time you call a uniform time course, the dimensions of the results are defined by the selection list, right? And but I mean, it's the selection list on one dimension, and it's all this information, like the 50 steps 0 to 5 or whatever on the other dimension, right? So so uniform time course will always give you a particular. It is a 2D matrix.
No,
yeah.
Just here, result is like probably it depends on what is in the simulation. What is in the selection of the simulation of the freedom. It's still on this. It depends on you select the Jacobian on one side for your model, then you have the Jacobian.
That's different though. I mean, that's not a uniform time course. That's a Jacobian.
It's not 2 dimensions. It's whatever. It's at least
So you just want to define like when you load it in, right? Like your external data, your SZ data, is that what you're talking about? Or is this something else?
Just don't want to make assumptions in point. It's kind of a general.
Sure.
Maybe you have to walk into
To find out what the dimensions are, yeah. I mean, I could see. I mean, the fact that I am comparing it here means that this data should be the same dimensionality as Sim1, right? Right. But other than that, I don't. The language doesn't care as long as like this function works somehow. I mean, I didn't say, oh, like I could say like, whatever, you know, like it equals row first or something. Oh, right.
Also the order of the dimensions. The three dimensions first. The data dimension could be stored first. It's more times the set data.
Okay, so something like this, yeah.
No, it's just one. It's comes as a single.
That would be fine. This is all this has all the definitions right. If you want a Jacobian script, it's a completely different script, and that's fine. You can do that. You define your indexes or whatever. You just call it. The Jacobian, the only thing, so everything local is defined like this. Okay.
You select up there.
Yes.
The Jacobian.
No, that's not where you select. That's not where you define the Jacobian. The Jacobian is in the script. It is a function like uniform time course.
You can only select one element thing. So I could imagine if you have a select.
It would be something like this here. It would be in the script itself, right? I would say JC1 equals execute Casal. And you would have to know that 65 is the Jacobian, and then you would say like, right.
You put at the selection which gives you
A selection. What do you mean a selection?
Yeah, you could select a set.
No, the selection list is just variables. It is specifically, well, and that's why I think we actually probably should move it to the uniform time course. So let's take it out of here. Yeah.
Exactly, and so it's 100 times 1, for instance. You run a time course for 100 steps, 100 times 1. And then your result is not, as your definition of the result here, then it's 10 times 10 times 10 times 100. Because you have to store the 100 value somewhere. So, and where is the 100? It's 100.
This one just there's a sum of squares. So I run my uniform time course. I move the selection list into here.
Oh, okay.
And then calculate the sum of squares, and then put that as this is a double, and then I put it in there. I broke it down to single value. Yeah. I mean, you could assign it to something else. Like, I mean, like in Python, you would actually just do, like, even if I didn't do sum of squares, and if I just had sim1, you could just store it, and it would be results alpha, beta, zeta, sim1, right? Like, and then it would be itself be another a dimensional, multi-dimensional data.
You also have a selection list contain a selector of what you want. Like if you have species here, whether you have the species rate, concentration, the amount.
I lost you. Sorry. Yes, I would imagine that you could do that. Like, we should find out a way to do that. That is an important thing to do.
No, because right now, earlier you mentioned you rolled all that into the execute result stuff.
Oh, but not in the uniform. Oh, yes. Okay. Let me see here. Ah, yes.
I say yes.
Yes. That is what we do. Yes, that would make sense. And you would just have to define a mapping between a string and what that means.
I mean, the selection is controlling the object, and then we have a filter to get out of it.
Okay. Yeah.
In that regard, can you just sort of suggest the polls out actually something like CSV, but maybe CS5? There are anything there and it's self-described.
Yeah, I think certainly what yeah. If when everything is a dictionary or array, it absolutely stores as HDF5, and it might store as CSV if it's only two-dimensional. But yeah, people definitely said, like, let's just have our standard output as HDF5.
Also then keep it stored in the other order of the dimensions, people can still easily resolve.
Yeah.
I mean, the R change the things. So may change the order and so you need the labeling to change the R.
Yeah.
Depends also on your operating system. Yeah, it can be more performance to store it in the other way.
Yep. So I guess the question is what the thing work doing this, or you got
An alternative idea, yeah. Yeah, is
We won't know unless we have more examples. What can we do now that we can do?
yeah, exactly.
so there was a big old list of that we came up with at that same harmony of like, let's do all these different things. And I actually like worked my way through a bunch of them, and several of which I put in as we went. But the basic thing is, yeah, it's continue to sort of define those things. The external data. Oh, yeah, how to parameterize Vega, right. Oh, that, yes. Yeah, and how to parameterize the external stuff. All I can think of is like have some sort of generic parameterization object, and it's just like parameterize this string as this other string, and then hope that, and then make each format define what it needs.
Yeah, global variables up to that point.
Yeah. Just have your global variables imported somehow, and each one would know what that means. Or you could even list like which global variables you need if you don't need all of them. Like if you're only plotting, like if you're doing Vega, all you need are your data matrices. You don't need the model objects, right? So you don't need to worry about like, how do I translate this model to Vega? Yeah. Yeah. Okay. So yeah, if because that's how workflows generally work, is with files, right? It's like, so you just say like, here's the file that I will send this, and we can just have that be an HDF file, which we already can write a report for. Yeah. I think yeah. I do like moving the selection list to the simulation as opposed to having it in the model itself, because you're right, it seems to, if you wanted a default value or something, yeah, maybe both, I don't know. Okay. Does anyone have a completely alternative? Like, do you think that we should continue our declarative SED-ML and thing instead of doing a script? And so, like, this essentially is like, I want a script. I want to say like, do the XYZ in a row.
because we take all the complexity into the document scheme.
Mm-hmm.
That would be presumably completely different process.
Well, that's why I said like it would be nice to sort of coordinate with SED-ML and say like, can we use the same format mostly? Which I think, like I think a dot format, like IDs in SED-ML, just like IDs in SED-ML cannot have dots in them, right? Yeah, that's why I'm looking at them. But yes. Oh, it's a name that has to be the. Oh, and the names don't have to be unique. Okay. Okay. I mean, certainly for the things that don't have subvariables, it's just the ID. So. Or the. Yeah. 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 Right. Show the differences between the two of them. That could be interesting.
So do you have like a full set of keywords that you use in the format?
I have a bunch. I have these UML diagrams, which I guess are all the keywords basically, right? And where, yeah, you know, like here, there's my SED-ML, there's the model. All these are in the SED-ML. No, they aren't available yet. Well, I didn't put them in the SED-ML folder, I guess, but and I'm not showing you that because, oh no, I am. Okay, yay. So yes, basically all the attributes in children I've written out. I haven't tried to convert. I would like to use divisor to make a new libSED-ML2 sort of thing to see, and then I can start like messing with things a little bit more easily. But
One has included an XML dialect at the end, but
yeah.
So much of it will be index based.
Yeah. There's the MathML parts and there's. Are the like this weird.
We're not going to use the functions that we have in libSED-ML to evaluate these keynotes because the individual elements now will be objects are in scale.
Potentially, yeah, yeah. And we'll have to expand the like. There is an expansion for arrays that expands what MathML is usable in libSVML and the infix translator. So you can actually have an array like MathML object, but yeah. Yeah. Yeah.
Having the different formats, and since you for the YAML serialization use infix and for the XML one MathML.
Yeah. So one thing, if we do move to YAML, one thing we'll have to figure out is how to best annotate stuff. Because XML has an obvious way to annotate everything. And I don't know how best to use YAML to annotate things. But yeah. Yeah.
But if we go to YAML route, this is a great idea. We have a dispatch that implements all of SED-ML in YAML.
And you can call it from GitHub. Yeah, I could. That would be nice.
Open source, and you can just call it, and it'll call it and later whatever is necessary. But the entire language itself in the YAML format is supported directly as a workflow.
Yeah, that'll be really interesting.
It doesn't have to be in, right? It's just a Linux environment.
Yeah.
You can run locally, you can run on Flutter, or you can run on GitHub.
Yeah. I can easily see, I mean, most of the stuff I've done has been writing translators. So I could easily see it writing a translator to Python or perhaps target something else. And then the Python, you can run it. You could run the Python as a GitHub action. You could run, but then you could also run it locally pretty simply.
I think you should really consider what you use and how many you use it.
And it's
I know, what do they see?
what do they see? Yeah.
And at the moment, like, rather than having to get something online,
well, the user here, and you know, workflow things that it can do, and in the background, so you can tell it. Like the user doesn't see it, you know.
oh, I know.
See it.
I know that, but you try to do that with users as well. But the community, some other, things.
But I mean, that was sort of a benefit, right? I mean, because the community has come up with different ways of interfacing with SED-ML. Like you can have the Kapasi endless charts, and you can have GUI things, or you can have antimony or whatever. They all are different ways of doing things. Yeah.
Run this tool and have this it's an example of user.
I think you should say respect if it says something about what the recommendations for the user, right? Rather than using it, something like that. We'll just think about 701. And so they're not going to use it exactly how that's the one they use.
Yeah.
So you might have some kind of guidance in document.
Yeah.
And somebody can write it as a Windows app.
Yeah, exactly.
When they have to be developed, changes.
Why is China multiple? It's still talking right XML raw XML raw XML.
They could have found phrases.
That was SVML. That wasn't even SED-ML. Oh, it was SED-ML? Oh, it was SED-ML. Yeah. Well, I mean, like phrase-ML was like the one thing that sort of worked. Right? It hasn't really been updated, but yeah. Getting things into this format, like creating it, is difficult. And it's just inherently difficult because you want to take your Python script and translate it to this. And there's too many things that just won't work. If I switch to this, do you see this? You can see my screen. Okay, good. Yeah, like a GUI thing would be another thing. But if this is your Python and you want to translate this to SED-ML, then you can't, right? Like you defined a function here, and that's a Pythonic way of defining a function. And now I want to like take that and like translate it to SED-ML. Like that's not obvious how to do that. Or one of our earlier ideas was to have a subset of Python that would be translatable to SED-ML. So and write your own Python parser basically to translate these specific things to SED-ML. Another option is to have a Python API that is a package. So everything that's specific to SED-ML then becomes a Python package function. Like the model function is a Python thing. It is your API. Data description is your API. Model reset, set model, everything underlined in red is a function that came from your API. And then you can tell your API, record, run your script, export to SED-ML, and then everything it did, it recorded, and then it exports the SED-ML to that. Now the problem is that this loop didn't have anything to record, all you're recording is that you did this 5,000 times with different values for wherever your uniform time course is. All your set things, right? And I left out the setting beta and zeta, but all your set things just had local variables that you set it instead of like knowing that it was in a loop, which works. Like it's a really long, awkward SED-ML file, but it would be translatable. But ideally, you would want something that knew about the loops. You would want something that knew about the functions. And in order to do that, you'd need some sort of extra information. You'd either need to like be able to try to parse this file, or you need to be able to have extra functions that is like record loop or something, or like this is a loop function, or this is a function something. So it's more awkward. It's not just straight Python anymore. So, but yeah, creating SED-ML is an issue. Translating it to scripts. Once you have it, sending it out is much easier. Yeah, you could have a GUI to create it. Mm-hmm. Mm-hmm.
Then you turn it back into an executable.
Yeah. Yeah. Anyway, it's not the easiest thing.
We've written lots of libraries for developers. Maybe also can't get the prototype to use it as well.
Yeah, I can see that.
First of all, and my only option, right, is just dump chunks of Python somewhere else.
Yeah. Right. Yeah. You just.
I can,
done first.
We solve everything immediately, and then we can like try to make it more specific later.
Because that would be describing more of the black box thing that we have discussed with Harmony last time.
Yeah.
Right. Like everything.
Yeah.
But I mean, I guess. Comment about the annotations, now we have IDs, we can use annotations. I don't think we have to write all the annotations in the.
Oh, in the SED-ML itself?
We have IDs.
Okay. A metadata.rdf or something, yeah. Once you have an OMEX file with everything, I could see that. Just the two, I think. Build more prototypes, yeah. 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 Just make everything external and then. Yeah.
And figure out how to run that on the local chain.
All right. Thank you.
Waving to yourself.
No, I'm waving the recording.